Okay, in this new problem, we want to reparameterize this position function using arc length. And in the previous example, we summarize the steps of getting this done. So we want to find the arc function first. So now to find the arc function, we integrate. So we want to integrate t from 0 to some arbitrary time, right? So we're going to integrate from 0 to arbitrary time. I'm going to label that as t square root of the derivative of the first component square plus the derivative of the y component square. So basically it's 1 square plus the derivative of 2t is 2 square. And I'm not going to use t because I don't want to confuse u by that. I'm going to use another variable u, du. Okay. So du, and this gives me square root of 5 du, and after the algebra we have square root of 5t minus 0, which is just square root of 5t. So this is my first step. The second step, basically what you have for now is arc length is square root of 5t. So I want to solve for t in terms of s. So t is equal to s over square root of 5. Just divide both sides by square root of 5. And now I'm ready to reparameterize my RT in terms of RS, right? So what is t equal to? S over square root of 5. And then I have s over square root of 5. And then 2 times t, which is 2 times s over square root of 5. So this is how we reparameterize this particular one into arc length using arc length. Now let's look at the very last one. We want to reparameterize this. This is a circular motion, uniform circular motion, because it's a circle, and we use arc length as the parameter. So step number 1, let's find the the arc length function from 0 to t, square root of derivative of cosine and square, and then plus the derivative of sine square, which gives sine u square, right? Remember, we don't want to use t, we use another variable u, plus derivative of sine is cosine t square. Oops, I'm sorry, I just said that I want to use another variable, right? So cosine u square du, and this is 1, so basically I just have du, which equals t. Now what that means is s is just the same as t, so therefore I don't have to really solve for t, because it's already there equal, right? So I can quickly reparameterize my function in terms of s, because they are equal. So therefore cosine s and sine s, so they're the same function. And this is, they are actually the same, right? Now why this is the case? Here's the reason. Okay, here's the reason. If you look at r prime, which is negative sine t and cosine t, when we compute its magnitude, which potentially is the magnitude of the velocity function, it's equal to negative sine square, which is sine square, and cosine square. This is 1. Now if you remember, whenever this happens equals 1, we say the parameter t correspond to arc length s. So this is exactly the case. And when this happens, for every unit time elapsed, the arc length also change 1 unit. So that's what that means. So if you look at the previous example, so this is the previous example. In this case, the length of the velocity of the r prime is actually square root of 5. So in this case, every unit change in time, actually there's a square root of 5 unit change in arc length. They're not corresponding to each other like this one does. So this is not the parameter t does not correspond to s in this case.